Hey, this is Mr. Buss, and I'm going to walk you through the seed variation and natural selection activities that we did in class. And so this video is going to the first part of it's going to show the activity part, and then the second part I'll screencast as I go through and complete the document. So for the first part, we just looked at variation of a trait. And so, all individuals have a phenotype expressed, right? Phenotype is the physical expression of their traits and their genes. And there's variation in a population among individuals, right? So if we just take a bunch of seeds, sunflower seeds here, and we'll just say that this is a population of sunflower seeds, right? And we'll just look at the trait of seed length for these. And so, I know, of course, that sunflower seed size and length probably has a lot to do with the environmental factors that the sunflower plant went through, like if it was grown in appropriate nutrient-rich soil or had rain at the right times and so on. But and like if it was shady or sunny. But let's just for the sake of this activity assume that the trait of seed length is purely genetic. That's contributing, like, for people, like the trait of height has a huge genetic component to it. And so obviously there's going to be some environmental component as well, like if you're not don't get appropriate nourishment at the right times and so on, that can affect your height as well. But for this, let's go ahead and just look at the trait of length. So what I did in the lab, or what students did, is they just took a metric ruler and let me zoom in a little bit. We just placed the seeds on the metric ruler and, recorded their length. So like placed it at the 0, and then for like this seed, for instance, would be like, in millimeters, would be like 18 millimeters, for instance. And then they would record that and then do the next one. And then each student or group did about 20 of these. And so the results are here. So I would say this is what you can pause the video for a moment, and then you can go ahead and record in your data table. These are the group totals. So this would be not just one individual. This would be like for one class that we just did last hour. So seed size, record that. The seed size varied from about 12 to 21 for this class period. And then, for instance, there was like one seed that was 12 millimeters. There were 5 seeds that were 13 millimeters and so on, 11 that were 14. So go ahead and pause and screenshot this, or don't screenshot it, just go ahead and add this data to your write-up. And then you'll need this information as well. You'll need the average. So I just used a spreadsheet. I put all this information in a spreadsheet and just had the spreadsheet calculate the average was 16.7 millimeters, which, makes sense. It's right around there. Okay. And then the standard deviation, I had to calculate that as well. So one standard deviation of the data is plus or minus 1.6 from the average or mean. Remember, we use the word mean and the symbol is X with a line over it instead of the word average a lot of the time. So go ahead and fill out the data table. And in the second part of this video, I'll show you the graph that I made, and I'll walk through kind of how I added the lines to it. So that was part 1, seed variation. Just the setup for it and the actual running of it. Part 2, what we did is for natural selection is we took a cloth, and so there are different like cloths that we had in class and different colors and patterns and stuff like that. So we took the cloths and spread them out on the table, right? And there you can see that there. Okay, perfect. And then what we did is we took a population of seeds, beans in this case, black beans, pinto beans, navy beans, and kidney beans. All right, and then what we did is we spread the population of seeds out over the whole piece of fabric, okay? So that they weren't, and I'm just showing you part of this piece of fabric. We used the whole fabric and so on in class and whatnot, okay? And then we actually said, okay, let's pretend that this population of seeds, of course, the phenotypes that they vary in would be like a size phenotype, right? These two seeds vary in size, color phenotype. Might be, some of them are shinier than others and whatnot. So they vary in a few different phenotypes or traits. And then let's pretend we modeled and said, okay, let's pretend that these seeds represent like little bugs or beetles or something like that. And that there's a predator, and the students were the predators, and they said, okay, we're gonna turn the lights lower so it's hard to see, and then we're gonna have you hunt for these. And so students would like look away and then look down, and then they would like, they would remove the first one that they see. And then they would look away, look down, and then again they would remove the first one that they see. Look away, look down, and again remove the first one that they see. And they would just keep doing this for a time. And as they hunted them, they would just, since there were 40 total on here to begin with, there ended up being only 10 remaining. So when there were only 10 remaining, students counted up the survivors, and they put that in their data table. So that's kind of how we ran the second part of this, the natural selection part. So now I'm going to stop the video and I'm going to show you the write-up part, where I do the write-up for part 1, seed variation, and then part 2, I'll show you the data, and we'll do the write-up for the natural selection component of it as well.